Now at this moment, let's talk about the type of trap in RISC-V architecture. As you know, trap calls the CPU to stop normal execution of the task and jump to the trap handler. That is what the RISC-V code does when generating the trap. The trap happens in RISC-V architecture because of two reasons. First one is exception and the second one is interrupt. So whenever you think about a trap, I want you to think about the two possible reasons. The first one is exception and the second one is interrupt. Now let's analyze the RISC-V reference manual that describes the concept of the exception and the interrupt. We will look at the important point in this material. So let me read this important sentence. So we use the term exception to refer to the unusual condition occurring at the runtime associated with an instruction in current RISC-V heart. For the first time, if you read this sentence, it is sometimes hard to understand this sentence. If I explain this sentence in easier way, that is, the RISC-V heart, RISC-V core will generate exception during execution of the instruction. If RISC-V core goes through the memory overt or RISC-V heart cannot decode machine code. This is the typical case when RISC-V core generate the exception. Please note that exception is the type of the trap, and exception can be generated when executing the specific assembly instruction. Now, so let's move on to this material that is to describe what the interrupt is. That is another reason of trap. We use the term interrupt to refer to the external asynchronous event that may cause RISC-V heart to experience unexpected transfer of the control. So we use the term the trap to refer to the transfer of control to trap handler. Trap handler caused by the either on exception or on interrupt. So based on this sentence, we can think about important insight, that is RISC-V architecture and define the trap that is the move to the control because of unexpected event. Trap happens because of two reasons. First one is exception and second one is interrupt. So now that we got to know about the two types of trap in RISC-V architecture, let's dive into more about how to identify the type of trap in RISC-V architecture. So what you are looking at is the RISC-V specification that described exception code. Exception code is this value, the exception code. So 0, 1, 3, 2, 3. This is our score of exception code. And this table also show you the exception code. And one thing you have to understand is that the highest bit is important. In this case, this is 0, this is 1. Another important thing to understand is this exception code is updated to the machine code register or supervised code register when trap happen. So please note that this exception code is updated to the CSR register when trap happen. If you identify that highest bit inside mCOS register or supervised code register is 0, we can deduce that, oh, the trap occurs because of exception. If the highest bit inside this register has 1, this trap happened because of interrupt. So this is an important point whenever you first identify the trap in the trap handler. So if you actually use the debugging program to identify the value of the mCOS register and scOS register, you can see that and it has this value CDF, because this exception code is in the decimal format, and this decimal value can be converted into hexadecimal format, and F is the 15, JRXD is the 13, JRXC is the 12. The important thing is, in this case, highest bit inside this value is 0. So only you look at the value of mCOS register and scOS register, you can immediately identify the kinds of trap in this case. Then as for the second case where the trap happens because of interrupt, we can have the different value inside mCOS register or supervisor COS register. In this case, this register has this value. In this case, since highest bit is 1, this register has this kind of value. If the interrupt is supervisor software interrupt, it has 1 because it is specified in this table. But as for this kind of exception code, the highest bit will be 1 in this case. That's why the mCOS register or supervised COS register has this kind of value. As for this kind of interrupt, we will have this register will be updated to have this value, because score of exception code in this log is 5 and the highest bit is 1. In other words, if you convert this hexadecimal format into binary 1, you can automatically see that highest bit in case of 64 system, the 63rd the bit position has the 1 as for this case. So now that we got to know about the two types of trap in RISC-V architecture. Trap happens because of two reasons in summary. The first reason is exception and the second reason is interrupt. So that is an important point to understand. When the RISC-V core jumps to the trap handler, the first thing it does is to read the value of this register, and read the value of highest bit is the first thing to do. Based on this information, highest bit inside this register, another activity will be performed. So if the trap happens because of exception, and fault handler will be called according to value of the highest bit inside this register. And if the highest bit of this register is 1, interrupt service routine will be performed based on this value.